Hey everyone, this video is going to focus on a new way of writing a proof, which is called the flowchart proof. And then we'll also do a two-column proof and see how they're similar and how they're different. Right, so here's the diagram for the proof that we're going to write. Here's what we know. Angle ACB and angle ACD are supplementary. That makes sense because ACB and ACD form a linear pair. Okay. But we're also told that angle EGF, which is just kind of this random angle over here, and angle ACD are also supplementary, right? So these two angles are supplementary as well. And what we want to prove is that angle ACD is congruent to angle EGF. Right, so a lot of this proof has already been done. We just kind of have to fill in the blanks. So anything that's in an oval here is a statement, and then any time you see a box underneath the oval, that is going to be a reason. Okay. So this technically should be in a box because it's a reason. That's a reason. That is a reason. And that is a reason. So we have kind of ovals and boxes. All right. So we have here that angle ACB and angle ACD are supplementary. That looks familiar because it was one of the given statements. We can see the reason written underneath is given. Okay. But there was a second given statement, and so that's going to go in this other blank oval. Okay. And notice how things kind of flow left to right, and then eventually they flow down. I think that's just because they ran out of space over here. But usually this is the start of the proof, and then the end of the proof is going to be over here. Right. So let's copy the second given statement in this oval. Okay. Angle EGF and angle ACD are supplementary. Well, so now we should probably ask ourselves, what does supplementary mean, right? That is one of our key words. And usually if you see a key word, it's probably going to lead to the next statement. Okay, so supplementary means that things add up to 180, which is exactly what we see here, right? The measure of the two angles adds up to 180. The measure of these two angles adds up to 180, right? So all we're using here is basically the definition of what the word supplementary means. Okay, supplementary means things sum to 180. So our reason is just going to be definition of the word supplementary. Okay, that's what allows us to write that the angles sum to 180. Okay, now interestingly, here are two statements. The arrows point to a single oval. So we need to somehow combine these two statements into a single statement. Well, let's see, how can we do this? We've got the sum of two angles here, which is equal to 180 degrees. And we have the sum of another two angles, which is also equal to 180 degrees, right? So the commonality between these two statements is that they're both equal to 180 degrees. Okay, so if this expression is equal to 180 and this expression is equal to 180, then we could conclude that these two expressions, the orange and the green, are going to be equal to each other, right? Since they're both equal to this common value of 180. Okay, and so we're going to combine these statements to write a new one. So the measure of angle ACB plus the measure of angle ACD. And instead of saying that it's equal to 180, because I already know that, I'm going to say that it's equal to the sum of these two angles. The measure of angle EGF plus the measure of angle ACD. Okay. Could have made that oval a little bit bigger for us, but that's all right. All right. So that was using the transitive property, right? One expression is equal to a second expression, and that second expression is equal to a third expression. So the first and the third expressions are equal as well. All right, if we follow the arrows, right, the next thing is that we just have the measure of angle ACB, which we see here, is equal to the measure of angle EGF, which we see here. And so we've lost these two angles, right? Measure of ACD and then measure of ACD. Well, that makes sense because we have the same thing on both sides. We can subtract it away from both sides to remove it. And that's what we see here as the reason, subtraction property. Okay. So this term was subtracted from both sides, right? So that all we had left was this angle on the left and that angle on the right. And then we're going from a statement of equality to a statement of congruence. Okay. So if the measure of one angle is equal to the measure of another angle, then the two angles are congruent to each other, right? And that is really just the definition of congruence. Okay, definition of congruence. Okay. When two angles have the same measure, then they are congruent to each other. All right, so that's our flowchart proof. And now what we'll do is we'll try to write it as a two-column proof as well. Okay. So I'm going to go ahead and write the two given statements here. Angle ACB and angle ACD are supplementary, and angle EGF and angle ACD are supplementary. Okay. So that's my first statement, and it's just given. Okay. And then as my second statement, I'm going to write these, right? Because I know that supplementary means that things add up to 180. I can write this equation out, and I can write this equation out. So the measure of angle ACB plus the measure of angle ACD equals 180 degrees. The measure of angle EGF plus the measure of angle ACD also equals 180 degrees. That's the definition of the word supplementary. Right. If I follow my flowchart proof, the next thing we did is we kind of combined these two equations into one. Okay. So the measure of angle ACB plus the measure of angle ACD is equal to the measure of angle EGF plus the measure of angle ACD. And that was the transitive property of equality. Okay. One expression is equal to a second expression, and that second expression is equal to a third expression. So the first and third expressions are also equal. Right. And then we see that we have a common term on both sides, right? Measure of ACD. And so we can subtract that from both sides, leaving us with a much simpler equation. The measure of angle ACB is equal to the measure of angle EGF. And so that's the subtraction property of equality. And then because we know that the measures of the angles are equal, then the angles are congruent. So angle ACB is congruent to angle EGF. And again, we're just using the definition of congruence. Okay. So that's one proof, but just two different formats, right? The first format was this flowchart format, which some people prefer, and the other format was the two-column proof, which this is kind of like the more traditional way of doing a proof. Okay. So you know, you can do it either way you want, right? Whichever format you feel works best for you. I will probably default to the two-column proof, again, just because it's the traditional way of doing things. But if you like the flowchart style, by by all means, right, go ahead and use that.